Hello everyone, this is Miss Chelsea, and today we'll be learning about chemical reactions and the law of conservation of energy. Our standard of the day is S8P1F to construct an explanation based on evidence to describe conservation of matter in a chemical reaction, including the results between different products and reactants. To do so, we need to know what is a chemical reaction. A chemical reaction is the process in which atoms are rearranged to create new substances. The substances that you begin with in a chemical reaction are called the reactants. The products that form as a result of the chemical reaction are called products. During a chemical reaction, all of the atoms that are in the reactants will also be present in the products. They will now be rearranged into new substances. Chemical reactions are represented by chemical equations. Before we look at an example of a chemical reaction, let's review a little bit about chemical formulas. The small number following a chemical symbol, or the symbol which denotes how many atoms the molecule has of that particular element, is called a subscript. In the chemical formula H2O, we have 2 hydrogens because the subscript after H is 2. We have 1 oxygen because there's no subscript after oxygen. This is because if an element has no subscript, the number of atoms is 1. One thing you should note is that subscripts cannot change when balancing an equation. The subscript tells the viewer the chemical formula. If you change the subscript, you would change the compound. The coefficient, on the other hand, is the large number in front of the chemical formula, which tells how many molecules are used in the chemical reaction. So in the chemical formula 3H2O, we have 3 molecules, and each molecule contains 2 hydrogens and 1 oxygen, for a total of 6 hydrogens and 3 oxygens. Notice how we took the coefficient and multiplied by the subscript to get the total number of atoms. Remember, coefficients are what is needed to be changed in order to balance a chemical reaction. So you can't change the formula, but you can change the number in front, the coefficient, or how many molecules you have. This equation, N2 plus 3H2 yields 2NH3, is an example of a chemical reaction. The molecules which start the chemical reaction are called the reactants. The yield arrow always points from the reactants to the products. Of these two below, you will see that the left side has the reactants circled, but the right side has the products circled. Now, a product is the molecules which are formed at the end of a chemical reaction. Remember, the yield arrow points from the reactants to the products. So in the 2 boxes below, the NH3 is the product on the left side, but the reactant on the right. In order to write proper balanced chemical equations, we need to remember the law of conservation of mass. The law of conservation of mass states that mass cannot be created or destroyed during physical and chemical changes. It can only transform into different substances. So, what does this mean for chemical equations? Well, if you look at a chemical equation, let's say you have CH4 plus O2 yields CO2 plus H2O. In that case, the carbons would be rearranged from CH4 to CO2. The hydrogens would somehow magically have 2 of them disappear or change into oxygen, and the oxygen would magically appear or be created from hydrogen. Notice how that is not okay by the law of conservation of mass. According to the law of conservation of mass, you have to have the exact same atoms before and after the reaction. They're just arranged in different ways. So in order to make this happen, we have to balance the equation. We have to have the same number of each type of atom on both sides of the equation. So we have one carbon on the left, one on the right. We're good. However, to balance the hydrogens, we would need 4 hydrogens on the right since we have 4 on the left. That means we need 2 water molecules. And once we do this, we're going to need to start with 2 oxygen molecules in order to have 4 oxygen atoms to make CO2 and 2 H2Os. So in this equation, once we balance it, no new matter was formed and none of the matter was destroyed. In this case, atoms are the matter. That means this equation is balanced. Remember, the amount of matter at the beginning of a chemical reaction will be equal to the amount of matter at the end. For example, in order to create water, the atoms of hydrogen and oxygen must rearrange to form it. If you were to measure the mass of both the hydrogen and oxygen atoms before and after they were combined, the masses of the reactants and products would be the same. This is true for all chemical reactions. The mass before has to be equal to the mass after. Now remember, matter can change state during a chemical reaction. If mass is missing, it is probably because some of the matter becomes a gas. So if you add the mass of that gas to the mass that you get in the chemical reaction, you would conserve the total mass. For example, when you make a campfire using sticks, the stick burns and it seems like nothing is left afterwards, but actually the matter is transformed. The chemical change occurred with a reaction to oxygen that resulted in ash, carbon dioxide, and water vapor. The mass of all the products will actually be equal to that of the original matter. When balancing chemical equations, the number of atoms within the reactant molecules must be equal to the number of atoms within the product molecules. So in the equation below, the reaction is actually unbalanced. N2 plus H2 yields NH3. Because on the reactant side, we have 2 nitrogen atoms, but on the product side, we only have 1. And on the reactant side, we have 2 hydrogen atoms, but on the product side, we have 3. This equation needs to be balanced to follow the law of conservation of matter. To do so, we will need to increase the amount of hydrogen on the left and the amount of nitrogen on the right. To do so, we put a coefficient of 2 in front of the NH3 for a total of 2 nitrogen atoms and 6 hydrogen atoms. Well, the nitrogens are already balanced, but the hydrogens are not. So we then have to add a coefficient of 3 in front of the H2, and 3 times 2 gives us a total of 6 hydrogen atoms. Now the chemical equation is balanced.